Yes, mate. More Venn diagrams. Don't get intimidated by the English. Lots of English in maths. Crazy that. But when you get to university, you won't even read a word ever again. It will just be a bunch of symbols. You won't even know what's going on. So hospital employees, 80 nurses, of whom 50 are full-time, the rest are part-time. Of the 44 male nurses, 27 are full-time. Represent this information on the Venn diagram show how males and full-time overlap. All right, so here they're basically telling us we're only talking about males and FT. Right. There are 80 nurses, of whom 50 are full-time. So that's this circle here. This circle here is 50. They said of the 44 males, so of the 44 males, 27 are full-time. So that's 27 being male and full-time. All right. Well, if there's 44 males, I ain't making this mistake. 44 minus 27 is 17. And then for the full-time lot, there's 50 minus 27, 23. Add them all up, they all add up to 80. So full-time was 50, 50 plus 17, 80 minus answer, 13. Cool. Part BI. A nurse is selected at random. Find the probability that they are female and full-time. Now here we have to be careful about the way we define this. So we're not going to say find the probability of F and FT. We're going to say females are not males. That's all. So we're going to say M dash. So they're saying what is the probability of M dash and FT? Okay. What's the probability of not male? So you could think of this as just being not male and full-time. So I want full-time, but I want nothing to do with the males. Okay, so 23 out of 80 in total, which I'm 100% sure doesn't simplify, but you can never be too sure these days. All right, part 2. What we got? Find the probability they are part-time given the nurse is male. So find the probability of part-time. So part-time means they are not full-time. So FT dash given male. Okay, so what's the probability of not full-time given male? Right, so we did our conditional probability statement in the last video, and I proved it to you. It says FT dash and male over, or given, we are restricting everything to the males. Now here, if you guys want, you can just talk about the absolute values, because both of these probabilities are over 80, right? And the over 80 is just going to cancel. So what is not FT and M? So I want M, I just want nothing to do with the FT. So that's 17 divided by the M's, M for M, is 44. Which again, I'm sure that does not simplify. 17 divided by 44. Nope, all good. 3 nurses are selected at random, find to 3 SF, all 3 are full-time. Now here we have to be careful, because we are choosing 3 individual people one at a time. All right. So find probability that all 3 are full time. Now we already said that there are 27 there's 50 full-time employees out of 80. Now once you've chosen one, there's going to be one less, 49 out of 79, and then 48 out of 78. Here they want it to 3 SF, so we're going to do 50 times 49 times 48, 80 times 79 times 78. About 0.239. Following that same idea, at least one is female. All right, so we've got to think about in terms of the males, right? So we've got 3 people. I want at least one of them to be female. So let's look at our options. If at least one of them needs to be female, we could have female, male, male. I could have female, female, male. And then I could have female, female, female. Okay? So, if you want at least one female, you need at most 2 males. Okay? 2 males, 1 male, no male. Okay? So we're actually asking ourselves, what is the probability of 2 males, 1 male, and no males? All right? So we're going to say, what's the probability of m equaling 2 plus the probability of m equaling 1 and the probability of m equaling 0. Okay? Is there an easier way of doing this? There is. You could think of this as which is the only option you do not want. Yeah? So you could do these 3 probabilities, or you could say the only option I do not want is having 3 males here. Okay? So the best way of doing this is doing 1 minus the probability of m equaling 3, which is 1 minus, how many males are there? There are 44 males. So 44 out of 80, so that's choosing 1 male. Then to choose another male would be 43 out of 79. Then choosing another male would be 42 out of 78. So 1 minus 44 times 43 times 42 over 80 times 79 times 78, about 0.839. And that's that. That's quite an important part because a lot of students, they might get it right, but they're going to waste a lot of time, okay? Because here you have to think about the permutations as well of getting 2 males, yeah? Because you could have 2 males, you could have MFM, so there's actually 3 different combinations you can have here. For this one, there's also 3 different combinations. M equaling 0 is actually 1 combination, so you have to times by 3, 3 and 1, which is a long process. Okay, guys, so now that you're aware of that, I'd really appreciate if you hit the like button, if you learned something new, subscribe for more maths content. If you're interested in my A-level maths courses, more details in the description, and feel free to head to the Lung Gang Reddit page if you want to submit your own questions and get feedback from the community. I'll see you guys in the next video. Nice.